Hi there. The purpose of this video is to determine by experiment the magnetic inductance and permeability of a steel core inductor. We have a circuit here where we've got 50 Hz AC power supply. We've got a coil here which has got resistance, which has got inductance. The resistor value is being measured previously is 6.3 ohms. And what we're going to do here is we're going to measure the currents and voltage flowing in an AC circuit, and from that we're going to determine the inductance value of the coil, both with a air core and with a steel core. And when we have these two inductance values, we will divide them out, and that will give us the magnetic permeability of the steel core. In a further video, we will verify the permeability value and the inductance value by the formula which uses the physical parameters of how the inductor is built in terms of the number of turns squared, the cross-sectional area and its length. So what we're going to do now is air core, there's no steel core in it, air core 625 turns. We've got a voltage going in. What we're going to measure that voltage going in is RMS. So we measure that voltage as 6.9 volts RMS. We measure the current here, which is 800, we'll use 850 milliamps. The voltage across the resistive part of the coil is Ohm's law, current times the voltage, which is 0.85 times 6.3 gives us a voltage of 5.355. To work out the voltage across the inductive part of the coil, we will use Pythagoras triangle. So what we do is we take 6.9 squared, we minus 5.355 squared, we get the answer to that, we take the square root, and we get a value for the inductive voltage of the coil at 4.35. To work out the opposition to current flow from the coil in an AC circuit, Ohm's law again, 4.35 divided by the current, which is 0.85, divide 0.85, and we get a value of XL of 5.11. We then take that value of 5.11 ohms, we divide it by 2 pi times the frequency, which is 50. So we divide by 2, we divide by 3.14 for pi, we divide by 50, and we get a value for the inductance of the air core coil is 0.016 henries, which is the calculations here. So by measurements, we take the voltage and current, and through the formulas we can work out XL, and we can work out then from XL, knowing the frequency, knowing XL, we can work out the inductance of an air core coil is 0.016 henries. What we're now going to do is we put the core in. The core is permanently magnetized a little bit. What we're going to do is we're going to now put the core in, and we'll put the output coil in there as well. It doesn't matter the output coil is there because we're not loading up the output coil, that's not going to matter. We've just got magnetizing current for the input coil. We've still got the same arrangements, but what we need to do now for the current will be a lot smaller, so we're going to put it in there, and we're going to ramp up the voltage to pretty much maximum, which will be about 29 volts RMS up to here, 29 volts. Okay, bingo, we got 29 volts. and what we're going to do is redo the experiment but with the steel core. So what we've got now is we measure the V in as, we'll call it 29.0. The current is 19.4 milliamps. So the current's a lot smaller because the opposition to current flow is a lot bigger. Voltage across the resistor is 6.3 times 0.0194, which is pretty tiny. So it's just 0.122. We can ignore that. So essentially the voltage across the inductive part of the coil is 29. We can work out the XL from that as 29 volts divided by the current, which is 0.0194. If we do that calculation, 29 divided by 0.0194, we get an XL value of 1495. If we take 1495 divided by 2, divided by 3.14, divided it by 50 Hertz, we get a value of steel cord inductance coming out to be 4.76 H. So there is that calculation there. So it's now steel cord. We've measured voltage and current, and we've worked out the inductance to be 4.76. What we can do now is, because we've got the inductance from the air cord and the steel cord, if we divide these two values out, for the steel we've got an L value of 4.76, and for the air cord inductance we've got 0.016. So we can work out the relative permeability dividing those two numbers out. The relative permeability of the steel core, if we divide those two numbers out, what we will get is 4.76 divided by 0.016. That gives a value 4.76 divided by 0.016 gives us a value of 297.5. So the relative permeability of our steel core, based on that experiment, dividing out the two inductances, comes out to be 297. So what can we say from that? If we look at the BH hysteresis curve plot of an iron core, steel core, what we can see is it's non-linear. So depending on the value of magnetizing current, field strength, the value of flux density you're going to get out will change. Ideally, this would be linear, straight line, and then you would have zero heat loss in the core. You wouldn't have any hysteresis loss. So it is a non-linear process, and to some extent the value of inductance is going to vary with magnetizing current. In a further video, in part 2 of this video, I am going to calculate the inductance value of the coil from its physical parameters, from its number of turns, which is 625, its cross-sectional area and its length. Thank you for watching.